All right, this is Geometry Lesson 6A, Applying Coordinate Geometry. The objective of this lesson is that you will be able to name coordinates of special figures by using their properties. As we go through this, you might want to have out your note card with all the different properties of shapes. It'll come in handy as we go through things. This does build on some of the stuff we discussed yesterday, such as the distance formula, the slope formula, and the midpoint formulas. Okay, so knowing you can flip back and forth to those might be helpful. So what we're kind of going to be doing today is we're not going to give actual numbers for the coordinates of these shapes. We're going to kind of represent these relationships using some letters and maybe 0 if it's on the axis. So here we learned about a triangle, and we see a triangle here. We see a mid-segment that goes through it as well. If you remember mid-segments, there's a few properties, such as they're half the length of the side they're parallel to, and they're parallel to a side. And so here you can see this triangle is placed in 3 different locations. In this first location, every single point has a different letter for each value, except for down here on the bottom, P and R. But you've got P is the values A and B, R is the values E and B, and Q is the values C and D. So you have a lot of different values for these different variables, and it gets rather complicated. Well, if you take that triangle and you slide it down onto the x-axis like they do in figure 2, it gets things a little bit simpler to understand. So now we've got P at 0, 0. Those are 2 numbers we understand. We've got R at C, 0. So we still have a variable in there, but we have 0 as one of our coordinates, which is beneficial. And then Q is up there at AB. So Q is still got these kind of random points we don't know much about. If we look at this third location though, where figure 3 where we put the triangle, this time we've got all 3 points on an axis, which is very beneficial, and each one is written as a multiple of 2 when they have something that's not a 0 coordinate. So P is at -2A, 0, R is at 2C, 0, and Q is at 0, 2B. The reasons why all of a sudden we put 2's in there is, well, if I was looking for those midpoints, I know I have to divide by 2. And so if I have 2 as a coefficient with these variables, when I divide by 2, those cancel out and I'm left with numbers that are nice. And that's what they're talking about in this next part. Okay. We can see that because if we're looking for figure 3, because of those 2's, these would be the locations of your midpoints, which are a lot easier to deal with than what they were in figure 2 up here, where you had fractional values for those midpoints. So basically what we're going to be doing today is we're going to take these shapes. They're going to be located in kind of helpful locations, hopefully attached to an axis, maybe with a location at a multiple of 2, and we're going to find various different coordinates using the information they gave us. So I'll go through a few with you, and then you'll kind of try some on your own. So here it says find the coordinates of each point. SQRE is a square where SQ, the top part, equals 2A, and the axes, so your x and y axes, bisect, meaning cut in half each side. So let's just think about this for a minute. This is a square. Things we know about a square is that all 4 sides are congruent. We also know that it has 4 congruent right angles. And these 2 facts can come in handy. So we were told that SQ, this top side, is 2A units. Well, that would imply that every single side is 2A units because it's a square and all 4 sides are congruent. Now the other thing they told us is the axes bisect, mean cut each side in half. That would imply that if the top side is 2A, half of it is A and the other half is A. And I can kind of go around my entire square and say, well, each one of these lines is A units. Using the fact that each one of those segments is A units, I could now actually find out some ordered pairs. So if I think about S, I can see it's A from the y-axis and A up from the x-axis. Well, if I think about those in terms of an ordered pair, I can see I went back A from the origin, that means my x value is a negative A, and then I went up A from the origin, meaning my y value is a positive A. And I can do a similar thing to go get Q. I can see that Q went to the right A, which is positive, and then it went up A, which is also a positive for my y value. And using that information, I can now get E and R. So I go for E. E went back and down. Back is a negative, and down is a negative. So it went negative A, negative A. Well, now I can see for R, it went to the right again, but then it went down. So going to the right is positive, but going down is negative. So I get those ordered pairs. So if I want to make my answer nice and pretty, because mine's a little bit of a mess, I would say S is at negative A, Q is at A, R is at A, negative A, and E is at negative A, negative A. Now, if this seems a little bit ridiculous, it's a little bit odd, but the purpose of this is to kind of get you thinking about the different properties of these shapes, but also this is a big ACT type question. So these are the types of things that they might ask you about on the ACT, so it's good to get exposed to them. All right, so here we're going to do the second problem together. This is TRI is an isosceles triangle. We know a lot of things about isosceles triangles. For TI equals 2A, so I'm going to say TI is 2A. The y-axis is a median. So first off, I think about isosceles triangles. That means there are two sides congruent. And then I think about medians. Medians go all the way back from chapter 5, and they connect two things. They connect a vertex to a midpoint. And using these two pieces of information, I should be able to find my three ordered pairs pretty easily. If I notice right away, T and I are on the x-axis, which means they didn't go up or down, so I know that T is going to have a y value of 0, as is I. Okay? Now, I'm told that this line right here, this y-axis, is a median, meaning this point right here, the origin, is a midpoint. These have to be congruent. So if that entire side is 2A, well, each little chunk is A. If I think about T, I went backwards, so that's a negative A. But for I went to the right, forwards, that's a positive A. I just got those two values. And now, I have to go get R. Well, I think about R. R is on the y-axis, which means it didn't go left or right. That means your x value is a 0. Now, we weren't told anything about how long from O to R is or anything about the other sides, so I just know that there's some height here, some distance on that y-axis that is moved. I don't know how much it is, so I give it just a random variable. I could give it B, C, D, etc. I just can't call it A as well because I don't know if it's the same distance as that part on the bottom. And those are my three ordered pairs. So hopefully you're getting some of the hang of this now. Using variable coordinates. So this one gets a little bit more complicated with our parallelogram here. It says, the diagram shows a general parallelogram with a vertex at the origin, so that's to help us out, and one side along the x-axis. What are the coordinates of D, the point of intersection of the diagonals of ABCO? How do you know? Okay, so here's what I would be thinking about. This is a parallelogram. I would go to my note card, and I would look up different things about parallelograms. So I know opposite sides are parallel. That's really not going to help me that much. I know opposite sides are congruent. Doesn't going to help me very much with those diagonals. I know opposite angles are congruent. Okay. I know consecutive angles are supplementary. Okay. And my last thing is that diagonals bisect each other. So that implies that this point D is equidistant from C and A and equidistant from the origin in B. Now, if you think about that for a minute, this idea of equidistant, that implies a midpoint. So, if I want to find D, all I have to do is find the midpoint of one of these lines. I think about the different points on these lines. On CA, I've got ordered pairs with B's, C's, and A's and zeros. But if I go on line OB, I have the origin is at 0, 0. And I have B at this thing right here. Well, it might be easier if I found, so what I'm going to do is I'm going to find the midpoint of one of these diagonals because both of them should be D. I'm going to find the midpoint of this line. I think for me that's going to be a little bit easier. So If you don't remember the midpoint formula, we did just talk about it the other day. I'm going to write it down. No, the midpoint is the sum of the x values divided by 2 and the sum of the y values divided by 2. So I'm going to find the midpoint of line OB. So I take my x values. I have an x value of 0 and 2a plus 2b, so I go 0 plus 2a plus 2b divided by 2. I do the same thing with the y value, so I have 0 plus 2c. And now I just begin to simplify. I know adding by 0 does nothing, so I'm going to just scribble those out. Now, it's pretty easy for me to simplify the y value. 2c divided by 2 is just a c. Now, if you remember though, when you're dividing a sum like this, 2a plus 2b divided by 2, both terms get divided by the 2. So I go 2a divided by 2 is a, and 2b divided by 2 is b. Oops, I wrote that in wrong. And it becomes a plus b, comma, c. Now, if you wanted to, you could also do this with the other diagonal, ca, and you should get the exact same thing. So the midpoint, or point D is what they rather asked us, is at a plus b, comma, c. So do you see why maybe having those 2's as coefficients with those ordered pairs makes things a little bit more simple for us as we go through? All right, and I know there are more notes after this, but I'm going to skip the coordinate proof because it is not something that is on your assignment. So this is actually going to be the end of notes for lesson 6-8. The objective was for you to name coordinates of special figures by using their properties. And this might even be your last notes for first semester. All right.